Alright, hey guys, I just wanted to take a couple minutes and talk you through the second half of this page because there's just no way a PowerPoint's going to be sufficient. So you should have already done 2A through D really, but let's talk through it. So for parts A and B, you were using that constant rate of change of 3.5 centimeters per minute and using that to find changes in height given how the time is changing. So for example, in part A, when the time increases by 2, so if 2 minutes goes by, the height of the water would go up by 7 centimeters. In 6 minutes, the height would go up 21 centimeters. In 7.8 minutes, 27.3. And the same idea on part C, it's similar, but now I'm telling you how much we need the height to change, and so you have to find out how much time needs to go by. So those really are parts A through C. So on part D, we would say, okay, this 0.7, 6.45, so we'd say at 0.7 minutes, the height of water in the tank is 6.45 centimeters. And then you could say the something similar for the next one. So at 10.3 minutes, the height of the water in the tank is 40.05 centimeters. So then it brings us down here, and these are lots of words, so let's kind of talk through it. So part E says represent a change in time, so that's important to note, of 2 minutes, and then we want to do it from that 0.7 minutes, so from that first point. So if I want to go to my table, the first thing I'm going to do, okay, so change in time. I'm not talking time, I'm talking about how my time changes. So we know from this 0.7, the time has gone up 2 minutes. So 2 minutes went by. So we were at 0.7 minutes, 2 minutes went by, so now we are at 2.7 minutes. Right? On my graph, I can take that, and again, I use my first point, and we want to go up 2 minutes. So we would represent that with a horizontal line. So that is my change in time of 2 minutes. Now then part DE says, then represent the associated change in height of water. And then we already found that in part A. So if you go back up to part A, in 2 minutes, the height goes up by 7 centimeters. So if I go back down to my table, so in that 2 minutes, my height is going to change by 7 centimeters. It was at 6.45 centimeters, we went up 7, so now we are at 13.45 centimeters. Again, on my graph, I can show that vertically. So here we would say we went up, so my change in height is 7 centimeters. So that actually gives us a new point on my graph. Sorry, it might be slightly off. So that new point is, hey, at 2.7 minutes, the height of the water in the tank is 13.45 centimeters. So that's part E. So now let's go on to part F. So part F says represent, still a change in time, but now of 6 minutes, and then we're still going from this 0.7. So really we're going to have to go back up to this original point. So on my table, so at 0.7 minutes, I'm going to go up now by 6. So again, from 0.7, if 6 minutes went by, now we'd be at 6.7 minutes. On my graph, right, so that's now going to be showing that horizontal line, but now that horizontal line is 3 times as long, because 2 minutes to 6 minutes is 3 times as long, which by the way means that my change in height should also be 3 times as much, right? So if it was 7 minutes before, we can come back up here and we see, yep, that's true. My change in height is 21 centimeters. So I'll come back down here. And again, we're still going from my original point. So from here to here, we've gone up by 21 centimeters. And I'm now at 27.45 centimeters. So again, I'm going to use my point. So I'm going to go up here. So this associated change in height is 21 centimeters. And so now we have this new point. This new point is 6.7, oh, that's a bit bad, 6, and 27.45. So that is my second point that I can add here. Okay, let's keep going. So let's do part G. So now we have the change in time of negative 3.1 minutes, and now we're going from our second point, this 10.3. So now, over here, we're going back in time. So we are subtracting that 3.1 minutes. We want to know what happened 3.1 minutes before the 10.3. Well, if I subtract the 3.1, I'm now going to have, I'm at 7.2 minutes. And in that 3.1 minutes earlier, we found that the height of the water was 10.85 centimeters less. So we actually need to decrease by 10.85 centimeters. So if I decrease by 10.85, then I'm now at 29.2 centimeters. And again, if I come over to my graph, I can still represent that. So if I decrease my time, oops, sorry about that. If I decrease my time by 3.1 minutes, right, so that change in time is negative 3.1, I'm actually going to go down, I'm sorry, I'm going to go down to that 29.2, right? And so this change in height here is negative 10.85. And so now we have a new point there. I feel like I'm a little bit off, but it's close enough. That is at 7.2 minutes. The height of the water is 29.2 centimeters. Right, finally, we need to do this one more time. And so now we need to represent a change in height of 18 centimeters, and we're still going from the second point. So for my 18 centimeters, right, we need to go up 18. And so now we are at, what is that, 58.05 centimeters. So if I want to go over to my graph, I need to go up, right? So here, my height went up by 18 centimeters. And that 18 centimeters we found took us 5.14 minutes. So here I need to add 5.14 minutes. So 10.3 plus 5.14 is just 15.44 minutes. So I'm going to go over here. Oops, got to move my graph a little bit. And we're going to say we went all the way over here. So this time that went by is that 5.14 minutes. And so that's going to lead us to this last point, which is the 15.44. And at that 15.44, our height is 58.05 centimeters. So that's really how this should look. And so it looks kind of messy, I know. Hopefully the color coding is helpful. But one thing I do want to point out, and it may not be perfect with my points, but I do want to point out that one thing we could notice, I guess I'll make it black, is that if we were to continue using the constant rate of change, just like we did this 4 times, so we could keep doing this. What if I wanted to change my time by 2 minutes? What if I want to change it by 2.3 minutes, 2.5, 2.7, 19 minutes, all those things? And we kept using the constant rate of change to plot points. One thing we would start to notice is that each of those points is going to fall on this line. And so that is actually always going to be the case. If two quantities are related by a constant rate of change, those points will always fall on the same line. And so as you, in theory, plot more and more and more and more and more and more points, those points start to form a line. They start to look like a line.